Name is the Cache and Furious. The problem statement we bring today is the agentic workflow for optimizing inference kernels. So, what is a kernel? A kernel is a small program designed to run on a GPU. It's the smallest unit of work that can be scheduled onto a GPU, and this one single kernel is run not once but thousands and millions of times on a single instance of a GPU. And so, it is very imperative that these kernels are heavily optimized so that they save energy, that they bring higher performance, and so on. So, what is the gap that we're targeting? The gap is that the vendor libraries given by companies such as AMD and NVIDIA only target huge, huge kernels and the most commonly used kernels that are used for training LLMs and so on, which includes general matrix multiplication and convolutions. What they miss out on is inference workloads. So we don't have highly optimized kernels for inference, and this could actually lead to huge multipliers of 2x and 10x in terms of performance. So let us explain
Um,
the code.
so, so, so if we talk about the code base, we have sort of built this harnesses, which is basically three agents. We have the planner, profiler, and the rewriter agent. So basically, you pass the kernel to the planner. It plans how should it be implemented. Then the rewriter writes it, and the profiler. So we also have NGP sim being set up. We pass on the kernel. It runs through the simulator, gets back all the metrics and stuff like that. So then the rewriter gets all the metrics based because profiler collects it and provides what are the bottlenecks, what can be improved, and the rewriter based on that rewrites it. So if you look at the iterations, we usually run 10 iterations, and now and yeah, so basically this. So we got a decently speed up in this case. Manathikunda.
All right, so moving on to our demo. So let's just look at a quick demo of how our actually system works. So yeah, this is our current thing. So on the left side, you have the unoptimized kernel that is currently running for a certain number of iterations. Meanwhile, on the right side, you have our optimized kernel. Now, as you can see clearly, there is a 7.5x increase and speed up. That just means that the AI optimized kernel, which we retrieved by running multiple iterations, is clearly superior. What this means is that in the future, on particular, let's say, edge devices, you can run much larger models much faster and much better. And that is the whole point, and that is the whole crux. So this transforms the GPU optimization from actually like a bottleneck into like some sort of advantage for all edge devices.